Our final lesson in Topic 1b has us evaluating series of arithmetic sums. An arithmetic series is just the sum of a finite sequence. Finite meaning you know the first and the last numbers in that sequence. It says, what is the sum of the terms in this arithmetic sequence? 1, 4, 7, 10, 13. So you may want to grab a calculator for today's notes. We'll be using a few formulas and things where you'll want a calculator to plug in to verify that we get the same result. If you're asked to write the sum, that means you're going to put this in series form. The form it's in is a sequence. To write it as a series, you literally just put pluses in between. Seems kind of silly, I know. But this is called a series, and it's arithmetic. Now, to find the sum, you'll literally add them together. What would you get if you combine 1 plus 4 plus 7 plus 10 plus 13? The answer? 35. That would be the sum of the 5 terms in that arithmetic sequence. That didn't seem too difficult to calculate, but what happens when the number of terms becomes more challenging to work with? Example, what is the sum of the first 43 numbers for the arithmetic sequence a sub n equals -2 plus 13? We could list out all 43 terms by plugging in n equals 1, n equals 2, n equals 3, all the way up to 43, write the formula as a series, and then add them all together, but that would take a while. There's a formula for an arithmetic sum that helps you determine the sum without having to know every single term in that sequence. We're going to write out a lot of definitions for this. Hopefully you can make this fit in the space on the left. Your arithmetic sum formula is S sub n. So the sum of n number of terms, no matter how many you're looking at, is going to be a fraction. Another n times a sub 1 plus a sub n. That's an n right there. Let's try that again. There we go. And then that's all divided by 2. These are the things you need to know. N is the number of terms. And if it's finite, we'll be able to know that answer. A sub 1, and it's important to actually write this out, is the first term that's going to be in the sequence. And there's a reason why we're stating it that way. The first term in the sequence. That's an n right there. Well, I'm just having troubles with n's today. Let's get that fixed real quick. There we go. Our first term in the sequence. And you may have to calculate that in order to use this formula. A sub n is going to represent the last term in the sequence. And you may have to calculate that as well. There are our definitions. We need n, a sub 1, and a sub n. Once you know those pieces of information, you can find the sum of all the terms in that sequence. All right, let's again look at our example on the right. What is the sum of the first 43 terms? That will indicate our n value for the arithmetic sequence defined as a sub n is equal to -2n plus 13. This would be the explicit definition. We need to figure out the first term and the last term. Well, the first term is going to be defined as a sub 1 because it says the first 43 numbers. So a sub 1 is going to be the first term, which means we're going to plug in 1 for n on the right-hand side. -2 times 1 plus 13. -2 times 1 is -2 plus 13 is 11. A sub 1 is 11. Now a sub n is our last term, and if we're trying to find 43 of them, that would be the 43rd term. That's our last term, which means we have to plug in 43 to our formula to figure that out. -2 times 43 plus 13. -2 times 43 is -86. But if I add 13 to that, we get negative 73. That's the last term in that sequence. Again, we know n, we know the value of our first term, and the value of our last term. Never mind my husband, he is picking up leaves in the backyard right now. So that's exciting. All right, he's gone. Let's carry on. When you know all those pieces of information, it's really easy to find the sum formula, but this is where your calculator will come in handy. Now to use the definition, S sub n equals, well, n is 43, then we would default that to S sub 43, equals n, which is 43, that's how many terms there are, times the sum of the first term, which is 11, and the last term, nope, there he is in the front yard now, which is negative 73. Not sure if you guys can hear that or not, but whatever. And then divided by 2. Notice there are no variables on the right-hand side. We can simplify this by combining like parts. Order of operations would indicate we would simplify the parentheses first. 11 minus 73 is negative 62. Divided by 2, if I plug this in, 43 times negative 62 is negative 2,666, but if we cut that in half, we get negative 1,333. Now that formula, when you practice it, will be much more efficient than listing the numbers all out. If you ever see a problem with that unique looking E symbol, that's just sigma notation. And what this means is that you're going to find the sum using the sum formula. We'll use the numbers located on sigma to help us define the terms in our sequence. In that sigma shape, the number on the bottom is going to be the first number, or the first term in your sequence, and you'll have to calculate that. The number on the top is going to tell you how many terms there are. That will be the last term in that sequence. After the sigma, they're always going to give you a pattern or formula to get that set of terms, and that will be the explicit formula. Instead of giving you a sub n equals and telling you how many terms there are, we'll utilize our sigma notation to get the pieces of information we need. Over on the right, find the sum. If we start at 1 and go all the way up to 9, there would be 9 total terms in this sequence. To get the first term, the number on the bottom is 1, we have to calculate a sub 1, and we just plug in 1 to our formula. They used I in this example, but you could use any variable you want. Normally we use n, but this is the same thing. 2 times I, which will be 2 times 1, minus 6, well, 2 minus 6 is negative 4. That's the first term. To get the last term, looking at that number on the top, that would be a sub 9. 2 times 9 minus 6. 2 times 9 is 18, minus 6 is 12. We now again have all the parts we need. We know what n equals, we know our first term, and we know our last term. To find the sum, we just use the same formula as up above. There are 9 terms. We write s sub 9 is equal to the fraction 9 times the value of the first term plus the value of the second term, last term, divided by 2. Negative 4 plus 12 is 8, and 9 times 8 is 72. But when we divide that by 2, we get a sum of 36. The first 9 terms in that sigma notation have a sum of 96. Let's use what we've learned about finding series and sums to work backwards. How can you write the series 2 plus 9 plus 16 plus ... plus 79 using sigma notation? That means we need to find an answer that looks like the example up above. We'll use that sigma symbol. We need to know how many terms we have, and we have to find the explicit formula. We have all the tools, we just need to figure out how to use them. The first thing we need to figure out is the number of terms. Now we don't know that, or we don't know actually how many there are because of that mysterious dot, dot, dot on the inside. So let's figure out some options here. If I look at the pattern, I see that I'm adding 7, and then I'm adding 7 again. So it looks like our pattern rule is adding 7 each time. Over here on the left, a formula to calculate the number of terms, n equals. If we take the value of the last term minus the value of the first term, and we divide by the common difference, that'll tell you how far apart those terms are. And we kind of talked about that yesterday. But to account for the fact that the first term counts as 1, we have to add 1 to that answer. So again, we'll take the last term minus the first term, divided by the common difference between the terms, and then add 1 to that answer. That should give us our total. Let's put that to the test. N equals. It looks like the last term is 79, and I'm going to subtract the first term, which is 2. Divide that answer by the common difference, which it looks like we're adding 7 each time, so I'm going to divide by 7. I'll get that answer and then add 1 to it. 79 minus 2 is 77, divided by 7 plus 1. 77 divided by 7 is 11, plus 1 is 12. There are 12 terms in our sequence. That will help us with our sigma answer. The other thing we need to know is our explicit formula. And we know that if we have a sub 1 and d, the explicit formula is a sub n equals a sub 1 plus d times n minus 1. Looking at that sequence, do we have enough information? If we know a sub 1, it looks like it's 2, and if we know d is 7, that's what we need. A sub n equals a sub 1, which is 2, d is 7, and now let's simplify. Distribute the 7 in and combine like terms. 2 minus 7 would give us 7n minus 5. Now that we have our pattern rule and the number of terms, believe it or not, we're ready for our sigma notation. What we'll do for our answer is we'll write our sigma symbol first. It doesn't have to look perfect, just try your best to get kind of that E shape to show up. Now the number on the bottom is the term we start with. And in our case, it looks like we're starting with the first term. So I'm just going to write n equals 1. On the top, we list how many terms there are, and that's where that 12 comes in. And then after that symbol, we write the pattern rule for each term in the sequence. And we calculated that to be 7n minus 5. This would be the sigma notation for the pattern 2 plus 9 plus 16 plus dot dot dot, some terms in the middle, plus 79. And now to find the sum, we have everything we need. So this is going to be the easy part. There are 12 terms. We said n equaled 12. S of 12, the sum of those 12 terms, is 12 times the first term, which is 2, that's up above. The last term is 79, and then we take that and divide it by 2. 2 plus 79 is 81. And 12 times 81 divided by 2 is 486. We'll finish up the rest of the notes tomorrow in class.